Recording. Okay, Bismillahirrahmanirrahim. Today what we are going to study, we are going to study the group 1 elements of the periodic table. Just for the sake of quick review, that is the group 1. Okay, that is group 1: lithium, sodium, potassium, rubidium, cesium and francium. So there are 6 elements that are found in group 1, and basically group 1 starts from the period number 2. Okay, lithium, sodium, potassium, rubidium, cesium and francium. The general trend you can see here, they all are metals and highly reactive metals. And when we go down the group, okay, from top to bottom, you can see here the proton number or the atomic number is going to increase. Why? Because lithium keeps 3 protons, sodium 11, potassium 19, rubidium 37, cesium 55 and francium 87. So what we are going to do, we will just have a little bit detailed study of that group 1. Basically this group 1 is also called lithium family, and generally this is also called alkali metals. So we are just going to study the group 1, that is the alkali metals. They are also called the soft metals. Okay, they are highly reactive, as we have studied that the most reactive elements that are found on the left hand side of the periodic table, and the least reactive elements that are found on the right hand side of the periodic table. And on left hand side we have metals, and these metals are what? We are starting our periodic table from the group 1, and that group 1 is basically the alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. Okay, now keep one thing in your mind: only first 3 of these are safe to keep in the school labs, and the rest are violently reactive. I'm just going to share one of the video, inshallah, during the class, that you will see that how they are reactive. Okay, just for the sake of that information, what are the physical properties? First of all, we are just going to study the physical properties. They are highly soft. Okay, among the metals, these are the soft metals. Their density is very low because they can just float on the water, and like metals, they are good conductor of heat and electricity, but they are softer than other metals. You can cut them by the help of a simple knife. They are lighter than the most other metals, and they have low density, because usually the metals have high density as compared to water, and when we just put any kind of metal like iron or silver or gold, they will sink down in the water, but in case of group 1 they will float on the water. Okay, when we go down the group, their density is going to increase. Why? Because their atomic mass is also going to increase. They have low melting and boiling points as compared to other metals. Now there is a general trend that you can just see here when you talk about lithium, sodium, potassium, rubidium and cesium. Okay, their softness increases when we go down the group. Why? Because now look at here, the softness increases: lithium, sodium, potassium, rubidium, cesium and francium. But like here, lithium is soft, sodium is little softer, potassium is softer still, rubidium is even softer, and cesium is the softest element. And their density, when we go down the group, density also increases, because density directly related to their atomic mass. The lithium mass is 7, sodium mass is 23. So when we go down the group, their density will increase also. As compared to the density, basically what? Density is the relationship of the mass and the volume. How much mass is occupying the volume. That's why its formula is mass per unit volume. So we are just comparing the density of the elements with the water. The water density, the pure water density, is 1 gram per cubic centimeter, and the density of lithium, sodium, potassium, rubidium and cesium and francium, like 0.53, 0.97, 0.86. It means they go heavy when we move down the group. And density is directly related to melting point. If the density is increasing, But the most interesting point is that their melting point is going to decrease. The density is increasing, it means their melting point is decreasing. They feel heavy, but their melting point will go to decrease. Why? Because their reactivity is going to increase. I'm just going to share one of the video here, and you will just feel happy the things that you have in case of reactive metals. And Bismillahirrahmanirrahim. I'm just going to periodic table. Yes, that one is periodic table, and periodic table, and this one. Okay, this is just one of the video. You can also search from the YouTube. And that is the video that I have also shared with most of the people, and this is one of the great video. Just okay, I'm just going to reshare my screen here. So my dear friend, okay, now the reaction of the alkali metals with water. I'm just going to share the screen and look at here. When you talk about the reaction, like lithium is the first element of periodic group 1. Now you can see here, when we put the lithium in the water, it will start to glow and it will produce a flame, and it will produce fire. And it now what is happening, it is just floating on the top of the water. It is not going to sink down. The second member, that is sodium. Now that is sodium. We are putting the sodium. Now look at here. It is also not going down, but it is producing the flame, and they are also producing different kind of spark. It means the reactivity of sodium is more than lithium when it reacts with water. That is sodium. Now explosion in slow motion. Look at here. Now what will happen if we drop a huge chunk of it in water? Let's find it out. Now this is the explosion of sodium with water. Now what about potassium? Potassium is highly reactive. Now look at here. In case of rubidium, which is the next member, within seconds it explodes. That's why these material, they are also used in explosive material. Now cesium, look at here, cesium. That is cesium. Now what about the next one? And finally francium, the most reactive element of the periodic table among the metals. Francium has no stable isotope and its longest half-life is 22 minutes. So if you have francium, now this would be the condition of francium. It's highly reactive and it's radioactive. Why it is radioactive? Because within 22 minutes it will just decay. Now it's about francium. So, my dear student, when you talk about these things, you must keep one thing in your mind. Now, when we talk about the group 1 elements, the group 1 elements which are highly reactive. So, this is all about group 1 metals. So you can see here when we go down the group, in the group 1, which are usually called alkali metals or the soft metals, their reactivity will increase. Now these are about the physical properties. Now we are just going to discuss about the chemical properties. As we have studied that reaction with water, when they react with water, they will produce the flame, the fire, the explosion, and when we go down the group, the reactivity will increase. Okay, lithium floats and fizzes, and sodium shoots across the water. Potassium melts with the heat of the reaction, and the hydrogen catches fire. What is the chemical reaction? What is happening in case of water? Like when we are putting the sodium in water, it will produce sodium hydroxide and hydrogen gas. Okay, sodium hydroxide and hydrogen gas. Remember one thing, there are 3 different kind of chemical reaction can be happen with water, with when we react the water with metal. Number 1, the water can produce hydroxide solutions. Number 2, the water can produce oxide solutions. And number 3, water cannot react or it will react very slowly. So the metals which are highly reactive, they will produce hydroxide solutions. Like sodium, when lithium, sodium, potassium, when they will react with water, they will produce hydroxide solution. If we have lithium will react with water, it will produce lithium hydroxide. Yes?
Can I go to the toilet, please?
Okay. And the topic was reactivity. When we go down the group, in case of group 1, which are also called alkali metals or the soft metals, when they react with water, they will explode and they will produce sodium hydroxide. Remember one thing, I'm just going to share my whiteboard. It's a general trend when we talk about the metals, the reaction of the metals with water. You have metal, basically there are 3 group or 3 classes of metals in chemistry. The most reactive or highly reactive metals, the less reactive metal or simple reactive metal, and in the last, the least reactive metals. The least reactive metals means they react with water but in a very slow way. So what are the least reactive metals? We have copper, first of all, copper Cu, silver Ag, and gold Au, and sometimes platinum also. But in your syllabus you have only 3 least reactive metals: copper, silver, and gold. Okay, the highly reactive metals like group 1 and group 2, they are highly reactive metals. The group 1 and group 2, they are highly reactive metals. Okay, now we are just discussing about lithium, sodium, potassium, rubidium, cesium, and francium. Okay, now they are highly reactive metals. When we move from lithium to francium, means when we move from top to bottom, their reactivity will increase. And remember one thing, when they highly reactive metals, when they react with water, they will form what? They will form the two things which is called hydroxide solution. They will form the hydroxide solution, and number two, the hydrogen gas. The hydrogen gas that is produced during the reaction of water, it basically, this is the gas which burns and it will explode. But in case of reactive metals, the reactive metals, when they react with water, what will happen? The reactive metals, when they react with water, what will happen? They will produce what? They will produce oxide solution. Normally they will produce the oxide solution. Okay, and they will also produce hydrogen gas. But in case of least reactive metals, okay, they will also produce oxide or no reaction. They will show usually no reaction because their reaction is very slow, so we can detect there is no reaction is happening. Or such kind of metals, like these metals are used in cutlery, in our utensils, as well as in our ornaments. So we are here to discuss the reactive metals like group 1, like there is lithium. When you talk about lithium, they will show the same trend in case of reaction. Like lithium, we have lithium, and lithium is reacting with water. It will produce what? It will produce lithium hydroxide. It will produce lithium hydroxide. What is the formula of lithium hydroxide? That is LiOH. Okay, this is the formula. In our previous class, when we were just discussing the chemical bonding, we have also studied that how can we produce the formula. Okay, just give me a minute again. There are three categories of
Yes.
metals. Yes, over to you.
So there are three types of metal: highly reactive, reactive, and least reactive. And in highly reactive, it includes group one, which is lithium to francium. And as it goes down the group, the reactivity increases in each metal, as we saw
Good.
in the video.
Very good.
And
And when they react with water, they will produce hydroxide solution and hydrogen gas. And
yeah,
basically, this is the hydrogen gas that will explode and it will get fire. Okay, hydrogen is highly reactive explosive material. So during the reaction, when they react, they will produce this thing, lithium hydroxide, and this is hydrogen gas. Now balance the chemical reaction. There is one lithium, two hydrogen, and there are three hydrogen. Okay, and there is one oxygen. So what will we do? When we put two here, it will become 4, and it will become 4 hydrogen and 2 and 2. Now is this chemical reaction is balanced. So the same pattern will be shown by the sodium. Like this is sodium, we have water, and it will produce what? It will produce the sodium hydroxide solution. Like this is NaOH, and that is hydrogen gas, and this is the hydrogen gas which is basically cause the explosion. So just balance it. Now in case of the same thing, the same pattern you can see in the group. So this lithium family or alkali metals or soft metals, why they are called soft? Because let's suppose you have one of the material, like I'm going to show here, like by the help of this, any kind of metal like this one. This is one sodium, and just you are just going to cut by the help of a simple knife. You can cut that sodium or any kind of alkali particle into two pieces like this one. You can just cut the sodium particle into two half. So when you cut the material, you will observe that after some time the shiny surface of the group 1 metal will going to dull. Why? Because they are highly reactive and they react with the available quantity of oxygen in the air. So they can also react with air, means especially with oxygen found in the air. So that's why in the school lab, when we are just going to put lithium, sodium, potassium in our school lab, we put these metals in oil, we dip them in oil, because we just want to avoid to react such kind of metal with the air. So again, I'm going to share the booklet. Can you please read out the material from their side, their chemical properties? Let's compare the reaction of lithium, sodium, potassium.
Okay. Number one, reaction with water. All three react violently with water, giving hydrogen and the hydroxide. Experiment. Uh, Drop of water and indicator. Lithium floats and fizzes. Sodium shoots across the water. Potassium melts with the heat of the reaction, and the hydrogen catches fire. Note the trend in reactivity. For sodium, the reaction is sodium plus water yields sodium hydroxide plus hydrogen. Sodium hydroxide is an alkali, so the indicator changes color. The alkali metals react vigorously with water. Hydrogen bubbles off, leaving solutions of their hydroxides, which are alkalis.
Okay, now this is one of your observation. You may be asked one question: what will happen when the group 1 metals react with water? What would be your observation? When the examiner is going to ask the question about observation, what does it mean? It means that you are just going to describe the material that you can see by your eyes. So you may tell the things. There will be the gas bubbles, but do not mention the name of the gas, that is hydrogen gas. Okay, do not mention the name, because you are observing, and by the help of your eyes you cannot see what kind of gas is this without any kind of chemical change or chemical reaction or chemical test. So what would be your observation? The observation will be the bubbles will be produced, the solution will get the fire, and the third thing is that if the indicator is found in the solution in the water, it will change color from green to blue, because because the solution is going to produce the alkaline solution. Now these are your observation, but when we go down in detail, what is the name of that gas that is being produced during the reaction? So you can say that the gas is hydrogen. And why the solution converted color from green to blue? So you may say that we have used the universal indicator. Universal indicator show the green color in neutral solution, like that is water. But when the water react with the sodium, it will produce sodium hydroxide, which is basically alkaline substance. So the next two, the reaction with chlorine, what will happen? The same pattern. When they react with the group 1, basically the group 1 react with the non-metals, especially halogen or group 7, they will produce salt. Like in case of sodium, the sodium will react with chlorine, it will form sodium chloride. In case of reaction with oxygen, that we have also studied in acid, base and salt. And if you have not studied acid, bases, salt in my previous lecture that have been uploaded on my YouTube channel, I have clearly shows that there are 4 type of oxide that are found in your syllabus. The metallic oxides, which might be basic oxide or neutral oxide. So what we are going to do, again I am just going to give the description of group 1 metals. These are the chemical properties. Again, Now this is the reaction of group 1 metal with the water. Now I am choosing the same thing. What will happen when the lithium will react with group 7? What will happen when the lithium or the group 1, I am just going to detail it. I am just going to write that that is group 1. That group 1 is reacting with group 7. What will happen? They will form what? They will form salt. They will form salt. Okay. Now the same equation I am going to show here, or any kind of non-metal, when they react any kind of non-metal, they will form salt or halide salt. That salt is called halide salt. That called halide. Why it is called halide? Because group 7 is also called halogen. So I am going to describe the another chemical property of group 1 here. That is, like group 1 we have lithium, and in group 7 the most common element that I am using, that is chlorine. And as we know that the group 7, they are diatomic substance, so chlorine is found in Cl2 form. Okay, now what will happen? They will form lithium chloride, LiCl, and the formula of lithium chloride is LiCl, lithium chloride. Okay, now balance it. There is one lithium, two chlorine. So what will I do? I will put the 2 here and it will put here. Okay, now Ibrahim, tell me, the equation is balanced or not? Is it balanced?
Yes, the 2 chlorine. Yes, it's balanced.
Okay, now the second element that I am going to have it, that is sodium. In case of sodium, and it is reacting with chlorine. Now the same type of chemical reaction will happen here. When we are just going to react the sodium with chlorine, it will also produce what? It will also produce 2NaCl or sodium chloride. The same chemical reaction. The halide salt and so on and so forth. Now this is the second chemical property. When the group 1 metals, they react, they are highly reactive. So when they react with any kind of non-metal, especially the halogens, that is called group 7, or simply this is called halogen. The halogens will produce the salt. And why they are called halogens? The word halo means salt, gens means producers. So they produce the salt when they react with group 1. That's why they are called halogens. Now the third property. When we just going to discuss about the third property, I am just going to describe one more thing here. That is very, very, very interesting. In my last lectures of acid, bases and salt, I have told you the term oxides. Basically, what do you mean by the oxides? Oxides are the binary compound of oxygen and they keep oxygen. Like for example, any substance which keep oxygen along with any other metal or non-metal, that is called oxides. Like carbon dioxide, carbon monoxide, phosphoric, nitrogen oxide, sulfur dioxide, sodium oxide. These all are oxides. Like carbon dioxide, this is an oxide. Carbon dioxide, this is an oxide. Water is also another oxide because here we have hydrogen and oxygen. And carbon monoxide and so on and so forth. Sodium oxide, these all are the oxides. Aluminium oxides. Okay, sodium oxide, aluminum oxide, zinc oxide. Now these all are oxide. Why they are called oxide? Because they have oxygen along with another substance. So these are the oxygen containing compounds. In our syllabus, in a broader way, we have 2 types of oxides. Basically, the things that are included in your syllabus, in a broader way, when you talk about oxides, there are 2 types of oxides that are included in our syllabus. One is called metallic oxide. One is called metallic oxide. Why it is called metallic oxide? Because it keeps the metal with oxygen. Means the oxygen is attached with any kind of metal. And the second group, that is called non-metallic oxide. Non-metallic oxide, they are usually called covalent oxide. Why? Because they make the covalent bond. Non-metallic oxide. So metallic oxide, they are also called ionic oxide. Why? Because they make also ionic bond. Why? Because in case of metallic oxide, one substance is metal and oxygen is non-metal. So what kind of bond they will make? They will make the ionic bond. In case of non-metallic oxide, they are what? They are also called the covalent oxides. Why? Because they also make the covalent bond. And they make the covalent bond. Why they are making the covalent bond? Because like in case of carbon dioxide, this is non-metallic oxide. Carbon is non-metal as well as oxygen is also non-metal, and they are making the covalent bond. Like sodium oxide, when we talk about the metallic oxide, there are further two categories of metallic oxide. Number one, that is called basic oxides. As why they are called basic oxide? Because their pH is greater than 7. When you talk about their pH, which decide the substance is acidic or basic, their pH is greater than 7 when they are dissolved in water. And the second substance, that is called amphoteric oxide. Amphot means double nature, means when they react with acid they will behave like base, or when they react with a base they will behave like acid. That's why they are called amphoteric, means double nature oxide. Okay, so we have basically 4 different type of oxide, but in a broader way they are called metallic and non-metallic oxide. In case of non-metallic oxide, they are further divided into 2 categories. Number one, that is called acidic oxide. Why they are called acidic oxides? Because their properties, they behave like acids and their pH is less than 7. And the second one is called neutral oxide. So that was the description that we have also studied in our acid, base and salt chapter. So a quick review about oxides. When we are just going to talk about the group 1 substances. Now this is group 1, which is highly reactive. It means they can also react with oxygen, which is found in the air. So what will happen? I'm just going to describe what will happen. This is group 1. When this group 1 will react with oxygen, what is the formula of oxygen? That is O2. When it will react with oxygen, it will produce what? It will produce basic oxide. It will produce what? It will produce basic oxide. I'm just going to give the detail of 2 or 3 substances here, and the same pattern you will observe in the whole group. Like the group 1, the first substance, that is lithium. When lithium will react with oxygen, when the lithium will react with oxygen, it will produce lithium oxide. In case of sodium, okay, now this is balanced now. In case of sodium, the 2Na will react with one molecule of oxygen and it will also produce sodium oxide. So my dear student, so it's about the chemical reaction or the chemical properties of the group 1 that we have studied here. Now I am again moving towards our ebook. Now the reaction with oxygen that we have also studied. The 3 metals also burst in flame when you heat them and plunge them into a gas jar of oxygen. They burn fiercely to form oxides. and these dissolve in water to alkaline solutions. That's why they are called basic oxide. The same trend in the reactivity is shown in all three reactions. Each time lithium is the least reactive of the three elements and potassium is the most. Okay, now when we talk about the reactivity as you go down the group 1, it means it will increase. And why do they react in the similar way? Because in our previous class we have studied that they are found in the group 1. Now look at here. Lithium keeps the 3 electrons. The first shell keep the 2, the second keep 1. Sodium has 11 electrons. The first has 2, the second has 8, the last keep 1. The potassium keep 19 electrons. Okay, electrons. Now first keep 2, then 8, then 8 and then 1. So you can see here they have the 1 electron in their outermost shell, means they have the same number of electron in their outermost shell. That's why they show the same pattern of chemical reactions. Okay, they are univalent, they are also called univalent, and that's why they are also placed in group 1 because they have only 1 electron in their outermost shell. Okay, why does the reactivity increase down the group? In the reaction in group 1 atoms, they lose their outer electron to gain the stable outer shell. The more shells there are, further the outer electron from their positive nucleus, so they are easier to lose. And that's why they will show more vigorous reaction. Okay, I'm just going to request you again, Ibrahim. Am I audible, beta?
Yes, sure.
Okay. Can you please read out from this site why are they so reactive?
Okay. Why are they so reactive? The alkali metals are the most reactive of all metals. Why? Because they need to lose only one electron to gain a stable outer shell. So they have a strong drive to react with other elements and compounds. In order to give up this electron, they become ions. The compounds they form are ionic. For example, sodium chloride is made up of the ions sodium positive and chloride negative. The alkali metals form ionic compounds in which the metal ion has a charge of +1. The compounds are white solids. They dissolve in.
Water to give colorless solution. So I'm just going to tell you by the help of one description, and again I'm just going to open my whiteboard here. Uh, this is the fact that we all are agreed the group 1 metals, they are univalent or monovalent. They are called univalent or the monovalent. What's the meaning of mono? Mono means 1. Okay, monovalent. Valent means valency, means their outermost shell keep only 1 electron in their outer shell. Mono means 1, valent means electron. They have only 1 electron in their valence shell. Okay, they have 1 valence electron. Okay, so they have only 1 electron in their valence shell. So why we are just saying they are called monovalent? Because they have only 1 electron. Like in the case of lithium, it will lose only 1 electron and it will produce what? It will produce the lithium positive ion. It will lose only 1 electron. In case of sodium, it will also produce sodium 1 positive ion. It will also produce sodium 1 positive ion, and it will only lose only 1 electron. In case of potassium, the potassium, it will also produce K positive ion, the same pattern of ions formation, because they have only 1 electron to lose. But what will happen here? If we have lithium as well as we have sodium as well as we have chlorine, so which substance will react with chlorine to form halide salt. As we go down the group, lithium, sodium and potassium, definitely the potassium is more reactive than lithium, so it will react with chlorine. Okay, but when the chlorine is going to react with lithium, the potassium will inhibit that reaction, and sodium will react more vigorously as compared to lithium. Why? Because sodium is more reactive. But why it is more reactive, I'm just going to draw the structure of lithium and sodium. As we know that lithium keep the 3 electron, the sodium keep the 11 electrons. I'm just going to focus on these two things, lithium and sodium, and you will just get the concept. I'm just going to draw the structure of lithium here. That is lithium. I'm just going to draw the structure of lithium here. And only I'm just going to mention the electrons. So lithium has 3 electrons. The first shell keep the 2 electrons and the last keep the 1 electron. And this is the positive nucleus of the lithium. And as we know that the positive nucleus tries to hold these electrons as much as possible, because the electrons, they keep the negative charges. Got it? Now I'm just going to draw the structure of sodium. I'm just going to draw the structure of sodium. We know that sodium keep what? Sodium keep the 11 electrons. So the first shell keep the 2 electron, the second will keep the 8 electrons, and the third keep the 1 electron. That is sodium. Now this is the positive nucleus of the sodium, and sodium keeps the 11 electron. The first shell keep the 2 electron, the second keep the 8 electron, and the third shell keep only 1 electron. So sodium has 3 shells as compared to lithium. Lithium has 2 shells. So now tell me, now we have 1 valence electron here and 1 valence electron here. Now Ibrahim, tell me, which element, lithium or sodium, will have the ability to lose electron in less time? They have 1 electron. Now which element will lose the electron in less time, lithium or sodium?
Sodium.
Why sodium?
Because it's more reactive.
It's more reactive, but look at here, the distance. If we have 3 shells, let's suppose you are sitting in your home and you need to move to your main door, which is 3 kilometers away. Okay, which is 3 kilometers away. That is more far from your reach. So what will happen? The person who is found on the door side, or any kind of thief who is just want to come from your house, it will move more easily because you are very far from this side. But the thief cannot move from this side because in that case it's very near from the main person. So the sodium will react more rapidly. Why? Because its outermost shell is very far from the nucleus. The distance of the nucleus, now look at here, the distance of the nucleus is very high as compared to this side. And we know that the nucleus, it keeps what? It keeps the positive charge. The nucleus keeps the positive charge, and this positive charge will try to attract the negative charged electron. And in this case in sodium, it also keeps the positive nucleus, and it will It is just trying to hold that negative electron, the outermost electron. So the distance from this side and this distance from this side, this matters. Sodium keeps more shells. It means the outermost electron has the ability to escape easily as compared to lithium. This is the thing that we are here to discuss. Why, when we go down the group in case of metal, they their reactivity is going to increase. Why? Because their shells are increasing. If there are more shells, it means the nucleus will have the less power to retain the electrons. That's the thing. Got it? Hello,
Yes.
Ibrahim. Okay, so that was the concept. Now I'm again going to share my booklet here. Now, basically, the periodic table is the half soul of chemistry, because in the periodic table you are just going to understand the basic concepts of the elements and their trends. It means you are understanding this. It means you are just going to understand the 50% of your syllabus. That's why I just tell to my student, please, 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 more focus on periodic table. Okay. Now, these are the few questions that I am just requesting you. Please get the snapshot. What is the other name of group 1 elements and why are they called that? Which bed describe the group 1 metals, soft or hard, reactive or unreactive? The group 1 metals show the trend in the melting point. What does that mean? Describe the two other physical trends of the group 1. One measurements in the table on the page number 168. You have your own periodic table, you may use it. So it does not fit in the trends. So if you can support it, what form when potassium react with chlorine? What color is this compound? What will you see when you dissolve in water? Will the solution conduct electricity? Explain which holds its outer electron more strongly, a lithium atom, sodium atom, that we have studied here and discussed. Explain why you think so. Rubidium is blue potassium in group 1. Predict how it will react with water and chlorine and describe the product that will form. So that was the thing that we have studied. I am just going to upload these things because these are the practice questions and you need to practice them. Meanwhile, I'm just waiting the things. Inshallah, we have another class tomorrow. Just tell me, we can have the class in the night or